Hello and welcome to my workshop, the Australian Inventors workshop. Today I'm going to answer some questions that have been sent to me over the last few months of the problems you're experiencing with 3D printing. Problems like you can't get the filament to stick to the tape on the board, and you can't quite get the level right on the board. Well, there is other videos that I've done about leveling the board, and things like there's too much plastic being extruded out onto your part. Now, a lot of these problems can be sorted out by the settings in Cura. So what we're going to do is we're going to set up a part that I want to use. It's actually like a propeller or fan rotor. We're going to set that up in Cura, and we're going to put the settings in ideal for that particular part and this machine, which would be ideal for 90% of 3D printers and jobs that you're likely to do. So we'll just fire Cura up and get started there. So right, let's open up Cura, and this is the normal opening screen. Now, first of all, we're going to set up Cura for the Anit A8. Now, let me see, layer height 0.1, that is fine. Shell thickness, this is the wall thickness of your part or your model. Bottom thickness 1 millimeter, that's fine as well. And if you hover over a particular area, a description comes up and tells you exactly what it is. Density of fill. Now then, this is how much material is put in the center or the framework of the model that you're building. Now, because this is like a little airplane propeller, I want 15% fill isn't going to be strong enough. It'll be light, yes, but not strong enough. So I'm going to alter that to 60% because I want it strong. Printing speed or print speed, millimeters per second. Now I think that's self-explanatory. 50 millimeters a second is fine. 2 inches a second is absolutely fine. That's the maximum speed. It doesn't mean to say it's going to do that speed all the time. When the printer head moves from one position to another, it's from a standstill, it'll speed up, then come to a maximum of this speed, then start to slow down again. So this is the peak maximum speed of travel. We're using PLA, so I find more successful 190 degrees C. Now this is the temperature of the actual extruder or the printer nozzle. Bed temperature 60 degrees is fine, somewhere between 50 and 60. Summertime, if it's a hot summer, drop this down to 50. Winter time, take it up to 60. That's fine. Now then, support. Because you know, it's, the fins or the blades then, you know, airfoil shaped. There's a lot in mid-air, so we're going to want support structure everywhere. So you saw the different types there. Touching the build plate, wherever the model touches the build plate, it'll have a support structure if you choose that one. We're choosing everywhere because there's 4 blades on this little fan rotor, and most of them are in mid-air, so you have to give a support structure to build it on. Otherwise, 3D printer can't build it. So we put everywhere in this case. Platform adhesion type. Now then, we're going to use raft. Okay, so rafting. This is the... It builds what it says. It's exactly what it says. It will actually lay down a raft area over the entire area of where the model is going to be. I find it very successful doing this type of part. Your filament diameter, right, whether it's 1.7, 2 millimeters, 2.5, that's where this goes in. You have to put in Cura certain information, otherwise you do get the problem where it is not extruding enough or it's extruding too much. So invariably this combination of print speed and this number here will result in you having too much plastic extruded. So if you can alter that several different ways. You can speed if you're not getting enough plastic, you can slow this rate down. If you're getting too much plastic, you can speed this rate up, and vice versa with this too. You can alter this setting here to give more or less with this percentage of flow rate. If you're getting too much plastic through the nozzle, you can drop this down to 90% or 85%. It's a little bit of trial and error. This is where you do it, and it's a combination of these things: the print speed and the percentage of extrusion. So this is set up for general purpose. And in fact, in our situation, I've altered these here because I already know the type of model that we are going to extrude. Now then, so we go into File, and we're going to Load Model File. There it is. Now then, it's a little small for what I want, but unfortunately I got to wait for it to stop loading before it'll allow me to before Cura will allow me to alter the size. So if you alter the size of it, all right, now it's giving me general information. It's going to be 48 minutes of runtime. It's going to take 2.39 meters of filament, and it's going to weigh 7 grams. But I want it a bit bigger than that, so you go to Scale. So if you notice, it's at 1.0. In other words, this is 1-to-1 scale, and it gives you the dimensions. It's 80 millimeters in the X, that direction, 80 millimeters in the Y, and 20 millimeters high in the Z. But we want to go a little bit bigger than that, so you can scale it or put in the dimensions that you require. So we're going to go 1.5, and it will automatically change the rest, and Cura will automatically, should we say, work out and write the G code. Now G code is the language that CNC machines understand, whether it's for a CNC router, a CNC lathe, CNC milling machine. It's exactly the same for a 3D printer. It's a CNC machine. There's only slight differences because you have an extrusion head, but basically it is very, very similar. If I wanted to alter the scale of this, in other words, if I wanted it shorter but the same in the X and the Y, same diameter, you unlock it, press that lock there, and then you can go into the Z and put a scale of 1, which would reduce it down to 20 millimeter. That's how to you know, sort of, if you wanted to alter the scale of an object, doesn't need to be a propeller, it can be anything, a little model of a person, robot, doesn't matter. You can alter the scale if you wanted it the same width. You leave the two top ones as they are, but if you wanted it shorter, short, fat and dumpy, then you just reduce this one. To do it, you unlock it. Okay, so now this is telling us with the support structure, the rafting, and set at the rest of these settings, it's going to take 2 hours and 25 minutes. It's going to take 6.9 meters of filament, and it's going to weigh 21 grams. So we're going to keep that. So we're going to export the, I haven't actually got an SD card in there, but I'm going to save it to, there we go, V2G code. The V2 here, right, is the type of G code, right? This symbol represents that it is actually for a 3D printer. Okay, so the first thing to do is we need to reference all the axes, or ref all. So come down here to quick settings. Okay, now some people say ref all or reference all. The general term is home all. So that's what we're going to do now. Okay, after homing the nozzle, what I'm going to do is I'm going to check the table for level. So it's necessary to turn all the motors off, but still run the 3D printer. So to do that, you scroll down, preheat, disable stepper motors. Okay, so what you will find is if you pick this up and move it from place to place, the framework just moves very, very slightly, and because you are dealing with about 1/1000th of an inch accuracy, it will actually move and it will put your table out of alignment. So what you need to do is adjust it so this piece of paper underneath the nozzle feels like a very weak magnet. You should be able to slide it under there like that. You see? I can get it under and I can just feel that nozzle. And I can actually push the paper underneath it, just. That is set right. So you try it in several different positions. A little bit too, that needs to go down a bit. There you go. See how the paper is just folding as I'm pushing it? You can just feel it. Here's where the main action takes place. That is beautiful. So you can lock your lock screws up at that, your wing nuts or whatever you want to call them. And now you know the table is actually correct. Okay, so you can see it's actually constructing a raft to make this on now. If you notice here, you see a ghost in effect. I had a little problem. I don't know what it was, but it just didn't want to do it in the right spot. So I think it might have been a little bit of a corrupt file, but it's so what I've done is I've repositioned the model in Cura, and it seems to be printing okay now. This is an absolute horrible print. The only nice part about it was the rafting, and that was the part I created. So, you know, I'm going to have to take everything off here. I'm going to have to take the tape off everything. It is a terrible print. So I don't recommend that one to any of you to actually print. You know, it's sort of a bit of a fact, I suppose, that not 100% of your prints or whatever you do in life is going to turn out the way you sort of expect. So, well, what you can say about it is the rafting turned out to be pretty alright. But everything else is basically crap. Look at it. Horrible. Horrible, horrible, horrible. Okay, so after that, or should I say this horrific outcome, I decided to, well, I went into Thingiverse again, and I have found a semicircular fan duct, which I've started to print, and of course it's a perfect print. In the bed, in the middle of the bed where it should be. So I would say that this is definitely, you know, probably a corrupt file, one way or another. It's horrible. So, okay, so I'll just let the machine, the 3D printer rather, print this out, because I'd like to see how this goes. I've had a lot of success with this, shall we say, 3/4 circle one, again from the Thingiverse. It was a full 360 one, but I've just cut that section out so I could film through. And it appears to work very, very successfully. So I just want to print this one out, and I'll do a couple of runs with this half circle one, and if you know, sort of I'll check to see which is the best out of the two, and if I find that this blue one is better than this semicircle one, I'll construct a 3D file myself and I'll upload it to the Thingiverse. So it looks like this is going to be a 100% good print, as you'd expect. So okay, I'll just let it go ahead, do some fast forward, not fast forward, but some high-speed photography, and we'll see how it goes. Okay, so there we are. So I think next time I fire the 3D printer up, I shall be using that. It's a real shame about this fan blade. I'm going to have to find another one. I'm sure there's bound to be another one somewhere, because what I want to do is I want to put a fan inside here and just gently blow some air, you know, circulating air around this to cool the power supply and the general area around where I'm extruding the plastic. But that wasn't to be. That's a total nightmare. So I hope you've enjoyed this video, and if you go to my YouTube channel, there's now 200 videos for you to choose from 3D printing to CNC routing. I do a lot of wood turning and different shop jobs that I do around here. So thank you for joining me, and bye for now.